In this video, we're going to examine lab safety for general chemistry, including Chem 118, Chem 120, and Chem 122. So required materials, the lab manual. For Chem 122, you get that online. For Chem 118 and Chem 120, you buy it at the EME bookstore. You're going to need goggles, not glasses, closed-toed shoes, nothing that shows your socks or toes. So no sandals or flip-flops or anything like that. You'll need a calculator, pen, canvas, and for Chem 122 and for Chem 118, you need a cell phone to upload your lab reports to Canvas. This is a picture of what goggles look like. You can buy them at the EME bookstore or at department stores. And these are general safety rules for all labs. You must wear eye protection in the lab, splash-proof goggles. That's really what these are. These are splash-proof goggles, okay? They give you full coverage of your face and especially your eyes, so they give you good eye protection. Okay, if you ever get chemicals in your eyes, you have to yell for help. We're going to call the EMTs immediately, but that should never happen because you're required to wear goggles at all times in the lab, even if you finish the lab. While other students are still doing the lab, you have to wear those goggles. So if you need help, you always call the instructor. We're going to put you under an eye wash. I'll show you what that looks like in a moment, and rinse out your eyes for 20 minutes at least while we call the EMTs. You shouldn't wear contact lenses in the lab, but the goggles would cover those up. Appropriate attire. So you want to minimize exposure of bare skin, okay? So you could wear a lab coat or an apron, but it's not actually required. Long sleeve shirts are good. You actually can wear short pants in the laboratory, though. If they're too short, if they go all the way up your leg there, you're going to expose your skin. So if you're working with acids and you're wearing short pants and you're sitting in a lab bench, you're going to have to be extra careful not to spill anything onto your skin. You shouldn't wear jewelry. If you have long hair, you're going to need to tie that back, especially when we're doing experiments with Bunsen burner. Okay. Shouldn't wear neckties or scarves in the laboratory. Gloves, we have gloves available, though generally they're not required. You need to work safely. Never work alone. Only work on experiments that are authorized. Keep chemicals and equipment away from the bench edges. Avoid unnecessary hazards by keeping drawers and cabinet doors closed while working. When you move around the lab, move carefully. Do not run, okay? Watch where you're looking. Book bags might be on the floor, so don't trip over those. If you do bring book bags in, try to move them to a location like near the front of the room where you won't trip over them. Never use flammable solvents. That means a liquid that can catch fire near an open flame. All right, never carry out unauthorized experiments. Discuss any unusual work with your instructor before performing it. We'll be the ones who call for accidents or injuries, okay? So that would mean that the police and probably the EMTs would come up here pretty quickly. If you have any spills, notify the instructor, okay? And clean up immediately. If you have any contact with chemicals on your skin, you should wash the affected area immediately. 15 minutes, probably not necessary for a tiny amount of chemical. Waste disposal. Do not throw waste in the sink. No solids in the sink. Do not use trash baskets to throw chemicals away. Do not throw glass in trash baskets. We have a special container for glass, which I'll show you in a moment. No eating, drinking in the laboratory. So don't even bring drinks into the laboratory. You're going to have to leave those outside. Don't chew gum or use tobacco or apply cosmetics in the lab. Stay off your cell phones unless when allowed. Do not test odors by direct inhalation. So the idea is to waft the odor using your hands to try to create a little bit of wind so that the odor comes to your face. Usually you don't need to smell anything in the laboratory. Clean up before you leave. That means the bench area needs to be cleaned. The top of the bench needs to be nice and clean for the next class. Put all of your things away nice and neatly. Just don't throw them into your drawers. If you need any special safety concerns for the experiment that you're doing, there'll be a safety talk each laboratory. Locate the safety equipment, the shower, the eye wash, the extinguisher, blanket, okay, the emergency exit, and the emergency telephone. We'll generally handle that. We have safety data sheets giving you detailed information about the chemicals that you're using if you want, but you could look up safety data sheets pretty quickly on the web. Academic honesty, no cheating, 0 grade for cheating or thrown out of the course. And we're going to ask you to sign a safety and honesty policy form before you can begin your first laboratory. So we're going to collect that and keep it on file. Safety equipment. So I talked about broken glass. There's a yellow container in every laboratory where we put our broken glass. In fact, if you actually break some glassware in the laboratory, do not clean it up. Never pick it up. Call the instructor. We're going to clean up that broken glass for you because we don't want you to get lacerated. Glassware is slippery when it gets wet or with soap. So you might drop it. If you drop it, let it drop. Don't try to pick it up, because if you try to catch it while it's falling, you'll probably push your hand into some broken glass and lacerate your hand pretty badly. Okay? This is the drench shower and the eye wash. So if you spill a lot of chemicals on you, the policy is to disrobe and get under this drench shower. It's going to be like a tsunami rinsing you off. Okay? You're going to have to move that chemical contaminated clothing from your skin before you use it. This is the eye wash, same area. Okay, this is where you put your eyes here. Then there's a foot pedal at the bottom that turns it on. Again, close up to the drench shower. Don't ever pull on this triangle here. And close up of the eye wash at floor level, located near the entrance exit of lab. This is more material for the Chem 118 students for their safety quiz. General guidelines for lab safety, personal conduct and preparation. Conduct yourself in a professional manner. No horseplay or pranks. Follow all written and verbal instructions. The biggest reasons for students having accidents in lab is not following instructions. Ask questions, myself or the GA. Prepare for the experiment by carefully reading all the assigned background material and procedures. Never work alone in the lab. Perform only the experiments and procedures that you're to do that day. No eating or drinking. In fact, no cups. No liquid containers in lab. Never apply cosmetics or handle contact lenses. Practice good housekeeping. If you leave a mess, you'll probably receive a deduction of points on your lab report. Okay? If you have book bags, as most people do, put them in a location so that they don't clutter the floor and cause a tripping hazard. Attire and personal protection. Wear shoes, closed-toed shoes that cover your feet. No flip-flops, no sandals. Don't wear loose or baggy clothing. Shouldn't wear dangling jewelry. Tie back long hair. Always wear splash goggles at all times in the lab. If you need them, you can wear gloves. Okay, we have those available in the lab, though I don't think they're generally needed for most experiments. Wash your hands before leaving the lab. Lab operations. When using a sharp instrument, carry it with the sharp end pointed down and away from you. Use caution with sharp incidents. If you're carrying glassware, use two hands, one underneath the container and one holding it by the side, and walk slowly. Examine your glassware before use. Check for dirty glass or chipped or cracked glassware. Broken glass goes into that yellow container. Exercise caution with fire and other heat sources. Never leave an open flame unattended. So if you have a Bunsen burner going, you have to turn it off if you're leaving the area. If heating a test tube, point the open end upward and away from yourselves and others. Hot liquids and steam can cause severe burns. Use caution when handling. Remember that objects usually look the same whether they're hot or cold, so you have to be careful when handling hot objects. Accidents and emergencies. Know the location and operation of all exits and safety equipment. We generally don't have band-aids in the laboratory. Okay. All spills and accidents must be reported immediately. All broken glass must be disposed of in that yellow container. You shouldn't ever have any splash in your eyes because you're wearing goggles at all times, even if you're finished with the lab and other students are still doing it. There would be at least a 15-minute rinse and then a trip to the hospital. If a small amount of hazardous chemical splashes on your skin, rinse it off. If a large amount splashes onto your skin or clothing, we're probably going to put you under the safety shower. Okay, you're going to have to disrobe and rinse because it takes a long time to rinse chemicals off of skin. Even a small amount of chemicals on the skin can have a lasting detrimental effect. It takes at least 20 minutes to rinse everything off. Chem safety. There's always some level of risk associated with any type of chemical. Okay, so you have to be aware of chemical hazards and physical hazards. You have to treat everything as though it could be a danger. Physical hazards are potential dangers to your safety posed by a chemical. For example, many organic chemicals are flammable, meaning that they burn. So there's an increased fire risk when handling them. Health hazards are associated with acute or chronic biological conditions that result from exposure of a chemical. For example, lead. We're not using lead in the laboratory though. Okay. General guidelines for handling chemicals. Double check the label so that you have the right chemical. Some chemicals have similar names. Only obtain as much of the chemical as necessary. Replace the cap after each use and screw the cap on. If you don't screw the cap onto the bottle, then the next person picking up the bottle might pick it up by the cap and cause it to spill over. Use a scoop or spatula to remove solids from a container. Don't handle chemicals with your bare hands. Clean all glassware before you leave. We have a sink for that. Dispose of all chemicals in the appropriate waste container, usually in the fume hood. Never return unused chemicals to the original container. This is a big one here because you might contaminate the original container. So it's better to waste some of the chemical than to return it to the stock bottle to reduce contamination. But you should only obtain as much chemical as you actually need. So you shouldn't have too much that you're going to throw away. You're going to have to keep some chemicals under the fume hood. All right, probably not for your general chemistry lab, but for the waste is going to be in the fume hood. 8, when transporting a chemical, always hold the container securely with 2 hands. 9, while working with chemicals, don't touch your face, mouth, nose, hair, or other body parts, or your cell phone. You'll be instructed on the safe handling of certain chemicals such as acids. Those are the ones, acids and bases are especially damaging to skin and eyes. Never smell or taste a chemical in the laboratory. Always wear protective chemical equipment such as the goggles and gloves when you need them. Be aware of hazards associated with each chemical that you're using. So you can look up safety data sheets if you're interested in the toxicity of chemicals. You can find these online. Type in the name of the chemical and safety data sheet. It'll pop up for you. Okay. The United States is using the global harmonized system of classification and labeling of chemicals. So it's in international use, like a UN thing. The system uses pictograms with graphic symbols to communicate hazards of chemicals. So it also uses signal words such as danger or oxidizer. It gives you hazard statements such as causes skin irritation. Gives precautionary statements such as keep away from heat and sparks or inhalation. It also uses pictures, pictograms. So these are some of the pictograms here. You'll see flame associated with a few of your chemicals in the laboratory. Okay, so when you're using a flammable, no open flame, no Bunsen burner. That's the big one there. The acids, especially, can be corrosive here. They can cause skin corrosion and eye damage, so be careful with those. We're not using any explosives. There aren't going to be very many where they can cause acute toxicity, but watch for the skull and cross bones there. Some are oxidizers. We'll be using some of these. Most of them would cause environmental damage, which is why we have a waste bottle. Probably aren't using gas cylinders. There may be some that may be slight risks of cancer. Okay. So then this is terminology associated with chemical hazards: acute toxicity, severe adverse effects, carcinogen, induces cancer, corrosive, a chemical that causes destruction of living tissue, skin and eyes mainly. Corrosive to metal means that it'll dissolve a metal in a vigorous chemical reaction with heat. Flammable, a chemical substance that is easily ignited. Alcohols would be examples of flammables. You have those at home probably. Most chemicals are irritants. Causes reversible damage. Okay, redness, swelling, itching, rash. You know what? You shouldn't have any symptoms associated with any chemical hazard because you're going to be safe. Oxidizer, a chemical that may cause or enhance the combustion of other substances. And poisons, most chemicals are poison. Self-heating, a substance that by itself through a chemical reaction with air will ignite. Sensitizers, a lot of chemicals are actually sensitizers. They may cause an allergic reaction upon repeated exposure. And you have to treat every chemical as being toxic. This is common lab equipment, beakers, which are not very accurate. If you see something like 100 mils on this, it's not very accurate. Filter flask, Erlenmeyer flask, conical, with a little tiny tip here, open tip here. Good for swirling chemicals because they can't splash out. Test tubes, graduated cylinders. Okay, so these are good for measuring liquids. Funnels, test tube racks, ring stand, wire gauze, iron ring, Bunsen burner, crucible and cover, evaporating dish, mortar and pestle. Ring stand, again here with a burette clamp. Burette. Volumetric pipettes, there's some safety associated with using these. So we'll have to give you some demos on how to use a pipette safety. It may look like it's pretty easy to use, but if you try to push a rubber bulb onto a pipette, it can break right here. And then the motion of the jagged edge could actually impale into your skin and through your hand. goggles, test tube brush, okay, forceps, tongs, you'll be using test tube holders, you'll be using scoop, forceps, and then some other pictures of these, of actual, instead of drawings, these are actual photos, graduated cylinders, volumetric flask, which we'll use a lot in Chem 122, burette and stand, beaker, tongs, Erlenmeyer, wash bottle. You got to check the label on the wash bottle. Most contain water, but some contain soap, and others might even contain alcohol. Ring stand, Bunsen burner, pipettes, spatula, watch glass, test tube clamp. You need to be familiar with all of these. Okay, so some actual pictures of a Bunsen burner on a ring stand, and these are air valves here. A test tube and clamp, tongs, graduated cylinder, Erlenmeyer flask, and beaker. All right, so that's pretty much it.